With me today is Dr. Jonathan Holzman. He is a professor in the School of Engineering here at UBC. So you are responsible for a little area. I'm going to call it little because we're going to be talking about small-scale machinery.
Yeah.
But an area here at the university called the Microfabrication Center. Yeah. What is that?
Well, the official name is the Applied Micro and Nanosystems Facility. And the way I think about this facility is it's a machine shop for small equipment. If you think about your ability to make something like let's say a birdhouse, I mean, ultimately you're using tools like a hammer, a drill press, etc. But when you try to make something small, imagine a microscopic birdhouse, you can't just make really small drills and hammers, etc. You have to start to use chemistry. So what we refer to as the microfabrication facility is the tool shop for these small items. We would have chemistry, chemical items, and pieces of equipment that are able to make microscopic machinery, if you will, for a variety of applications.
So, of course, in my mind, I'm picturing these little tiny, little tiny pieces of equipment. But you're talking about chemicals. You're talking about other types of tools.
Yep.
So what might that be, and what would we be making? You
know what a good example would be? It would be the old type of photography, where we began to put chemicals down on photographs and develop, etc. So we would be using that similar technology with chemicals, developing, etching, etc. But we would be doing it on a smaller scale, where we can control a lot of the light. And you would see a lot of these applications, for example, at Intel Corporation, where they would make little microscopic wires, etc. on a chip. Now we do that, but we also do technologies related to fluid flow, water quality sensing, etc. And so much of it all comes down to our ability to make these structures smaller and smaller and smaller.
Now this technology, it's already out there, or we have it in the university, we're doing research around it. What exactly is our role in using this equipment?
Yeah, well, I'll give you perhaps the most relevant example would be something we call microfluidics. It really highlights the multidisciplinary of our School of Engineering with civil, electrical, mechanical. Now microfluidics is similar to the microelectronics that you'd see in a computer, little Intel chip if you will, but instead of having electricity flow around on that chip, what we're doing is we're actually having fluid flow around on that chip. We're applying voltages to pull fluid around. So you could imagine your standard laboratory diagnostic tool, for example, glucose monitoring, DNA monitoring, etc., but shrink it down now to a small scale chip. And we're beginning to see now these technologies come about on USB chips, etc. And cracking one of those open will reveal what we call lab on a chip technologies. So it's a booming area, and so much of it comes down to your ability to make these impressive tools on a small scale.
So why has UBC taken that on?
I guess this is just my own bias. Because the School of Engineering is new, particularly at the Okanagan campus, we're looking at some of the technologies in the future. So we had no inertia, if you will. We could look at what we think is going to be big, and we do it, right? There was no sort of history for us, and so we can look at some of the technologies that will have a significant impact on society and jump on board.
So would you say that's the next big thing?
I would say so, yes. In fact, we're starting to see the introduction of some of those technologies, for example, the USB, glucose monitoring, etc. But I see so much more potential with these systems and their ability to benefit people by shrinking them down and carrying out these impressive feats of these large diagnostic tools.
How are the students engaging in this whole process?
The students have been involved from the very beginning. In fact, I love bringing them on board to show them the facility the very first time. We work in what's called a clean room facility, and it's a room that's extremely clean. We call it class 100. Every cubic foot, we have at most 100 particles of dust. So it could be thousands of times cleaner than an operating room, for example. And I always horrify these students by first suggesting that every minute, 100,000 particles of dust fall off your body. So the first thing we do when we enter is we dress up in a special white suit. We go inside and we try to prevent any of this dust from coming off onto our devices. Some of this dust could be bigger than our actual devices, so it would be like dropping billiard balls on it. So we have to be so careful how we control that environment when we're dealing with it. And we get a lot of students involved at the undergraduate level and the graduate level to make these own devices, solve their own microsystem problems, etc. And they're more than happy to do so.
That is so intriguing, and I think it'd be fascinating to be able to come and do a tour of the facility.
Absolutely.
Do you do that with the community?
Yeah, oh absolutely. No, we were created effectively as a partnership with a lot of local industry. So any involvement that we can have with industry, community, etc., we're more than happy to.
Great. Hey, thank you so much.
You're welcome.